We have in marketing three major problems right now. Problem number one, we are not delivering the kind of data that our stakeholders care about. In the 2019 Pricewaterhouse CEO survey, which was released in the middle of last year, CEOs were asked questions about what data do they view critical or important for decision making, and how comprehensive is the data they're receiving. The top yellow line shows you their critical importance. The bottom yellow line shows you how comprehensive the data is. Take a look. Data about your customers and clients' preferences and needs. 94% of CEOs say that's vital. Data about your brand and reputation. 90% say that's vital. Data about your risks to which your business is exposed. 87% say that's vital. But then look at the bottom side. How comprehensive is that data? 15%, 24%, 22%. We're doing, well, frankly, a terrible job of delivering data that decision makers in our organizations need to move forward, to move our businesses forward. And that's not going to end well for us. Problem number two, think about how much we invest in social media marketing, paid social, mobile marketing. We spend astonishing amounts of our budgets. In the 2019 CMO survey of chief marketing officers in August 2019, one of the data points was that CMOs are spending anywhere from 12 to 15% of their budget on things like social media marketing. And yet, when asked, to what degree does the use of marketing analytics contribute to your company's performance? Marketing analytics, which we barely invest in, outperforms mobile and social. So we're spending all this money on things that deliver less performance. This is not a good combination. Problem number three, why are we not doing more with our data? Well, it turns out because we just don't know what to do with it. Right? Look at the percentage of time marketing analytics is used in decision making. Again, from the CMO survey, up and down, most recently, 39.3%. Think about that for a second. We're using data to make decisions 4 out of 10 times. So what are we doing for the other 6 out of 10 times? Guessing? Making stuff up? Probably. And so this combination of bad data, underinvesting in data, and not using the data we have is going to lead to, well, unfortunate outcomes. So what we want to do is we want to pivot away from the things that don't work and figure out how do we get more out of our data. And one of those things is the profession, the field of data science. Well, what is this term? You've heard it a lot. You've seen it on LinkedIn top career lists. You've heard it mentioned at conferences. What do we mean when we say, what is data science? It is this. Data science is deriving meaningful insights from data using the scientific method. And the most important part of that definition is that last part, using the scientific method, using science, conducting experiments to understand what works in our data, what insights can we derive. Now, data science is composed of 4 major areas, right? 4 major types of skills. The first area is the business skills. These business skills are things like understanding the business, understanding what it is that our stakeholders are after, what are the problems that we're trying to solve, what are the challenges that a business would care about. One of the significant risks that we have in data science is that if we don't understand the business, we could be solving problems that nobody cares about, right? That's a very serious, substantial risk, is we could be solving for problems that nobody has. So we need those business skills. Our second set of skills are scientific skills, the ability to conduct experiments, to be able to scientifically control and make reproducible results. A lot of the times in marketing, think about what we do, right? We just kind of do stuff and hope it works out. How many of you have ever done like A/B testing, right? Do a website A/B test. You're like, well, what should we test? I don't know. We'll just pick something. Let's make that button green instead, right? That's not scientific. That's just random. So we need those scientific skills. The third set of skills we're going to need are mathematical skills, the ability to do things like statistics, probability, linear algebra, calculus, in order to understand and make sense of our data and find those hidden insights. And the fourth are technology skills, the ability to reach into data pools with things like APIs, writing code, databases, and data structures, being able to access data in order to engineer it and work with it. And you need all four, in relatively even amounts in order to be really effective in data science. So you're like, well, what about this? Or what about that? What about machine learning? What about AI? What about all this other stuff? Well, let's talk about, for a little while, what data science is not, right? Data science is not five things. It's not analytics. Analytics is the art and science of explaining what happened. It comes from the Greek word analine, which means to loosen up, to unlock, right? It's understanding what happened. Super important, very important skill to have, but it is not data science. Likewise, reporting is also not data science, even though the ability to present and communicate data is very, very important from an outcome perspective. Reporting is a separate function, and you would hear this in terms like business intelligence would be sort of more advanced reporting, not data science. Third, data science is not engineering, or engineering is not data science. Data engineering is actually its own profession in many ways. It is the ability to work with data, to store it, to structure it, to make it scalable, secure. Anytime you've got data sitting somewhere in your organization, whether it's in your marketing automation database or your CRM, there's data engineering behind the scenes to make that data available to you. Now, in data science, in those technical skills I mentioned, there are some aspects of engineering that you would need, but you're not fundamentally an engineer at heart. Fourth, of course, you are not doing statistics and data science are separate. Data science leverages stats very heavily, but statistics and being a statistician is its own profession unto itself. And finally, data science is not AI. The fundamental output of artificial intelligence is software, machines writing their own software. That's what we call a model. The fundamental output of data science is a theory, right? It's part of the scientific method. The outcome is a theory, something that you have proven through the scientific method to work. Now, you can take that theory and try to build software around it, and that's how the two would be connected, where you would take your theory and turn it into a model that a machine could then build. But they are separate. Now, why do you care about this? Why do we want to know what data science is and is not? Well, a big part of the reason is that there are a lot of folks who are trying to hire for data scientists, either individuals or agencies or vendors, and people love to throw all these terms around. If you're dealing with somebody, particularly a job candidate, who has skills in one of these areas, but not in the other skills in data science, but they're calling themselves a data scientist, you want to know that. You want to know, let's dig a little deeper. Let's see what else is under the hood besides the terminology checkboxes you've managed to say in the interview. Why do we care as marketers about data science? It sounds, all those skills can be so intimidating. It's like, is this really important? Is this really something we need to pay attention to? We care about data science for four main reasons. The first reason is that we want to be able to accelerate our decisions. When you look at that CEO chart, a big part of the reason why the data is not available to CEOs to make decisions is that they just don't have it. They're not getting it, right? So in order to help them make decisions, if we can use the processes of data science to get them their data faster, get them their insights, get them actionable insights faster, they can make better, faster decisions, or we can make better, faster decisions. We want that advantage of being able to make decisions much faster than just kind of waiting or winging it or any of those other things. Reason number two that we should care about data science is to lower costs. I am astonished at the number of marketers who will say, oh yeah, we're going to spend $1 million on this campaign. And you ask to say, okay, what's the criteria? What's the reasoning behind why you made the choices you made in your ad targeting for this campaign? I don't know. We're just going to run a campaign. Like, you're going to spend $1 million. Then you say to them, well, what about a little experimentation, a little measurement, a little proof of concept, testing the idea? Well, we don't have time for that. So let me get straight. You would rather potentially waste $1 million than spend $25,000 on data and analysis to know whether or not you're about to waste $1 million. If we use data science, well and properly, we should be able to lower those costs, lower those risks of failure. And believe me when I say that in the economic environment we are in right now, and you know this, you either work at a company like this or you have friends who work at companies like this, people are so risk averse, so risk averse. And if we can use science to lower costs and take away risk, they'll be much happier. We can use data science to beat competitors, particularly those competitors who are lagging behind, who are not ahead in their industry, finding out market insights, targeting customers better, being able to find out even disloyal customers or competitors and pull them away, using the scientific method to figure out what their customers or what the market really wants out of our businesses. And fourth, to find new opportunities, those blue ocean, green fields, white space, whatever, pick the color of your choice. These are the things that there are opportunities in our data. Our data today is so complex and so large that it is just unimaginable the kinds of intricate patterns that happen underneath the surface, like waves. Being able to pull out those patterns and say, here's a pattern we didn't expect to see. How can we take advantage of that? Real simple example. If you're familiar with the kids' toy My Little Pony, as a marketer, you would say, okay, that's clearly a product marketed for kids 8 to 13 years old, probably female. But you'd be wrong. Inside the data, inside that, you'll find a consumer base of men 26 to 40 years old called bronies that love this stuff and have way more disposable income. So if you're the manufacturer's marketing team, you're like, I would like to have more of the people with lots more money to spend, please. But that's something that you wouldn't see unless you were looking at the data, analyzing it, testing it, and coming up with an understanding of what the opportunities are. So let's dig into each of these 4 areas, starting with business skills. What kinds of business skills would a data scientist be expected to have? What is the purpose of having those business skills? The key is to be able to answer the question, what decision will be made from this? When you're about to run an experiment, when you're about to use data science in your marketing, you want to be able to ask, what decision are we going to make from this? What is the goal that we're trying to achieve? And that's something that, again, a lot of folks who are very junior in their data science careers or junior in sort of the analytics space overall don't ask this question enough. They go, I'll just do the thing. I'll do the thing that has been asked of me. No, what decision are we going to make? Because that's going to give us focus when we get to experimentation. Data without decisions is just a distraction. It's just noise. We want to know specifically, what are we going to be calibrating on? What, in many ways, what are we going to be testing to validate our experiment? Here's a simple example. We have this thing called KPI mapping. KPI stands for Key Performance Indicator. And the easiest way to explain a KPI is it's the number that you either get a bonus for or you get fired for, right? Your performance is on the line. Your end of year review is on the line for this number. So whatever that KPI is, we want to think about this and how we can use data science with it. So in a lot of cases, when people are asked for their marketing KPIs, they vomit like 30 or 40 different numbers: website traffic and conversions and leads generated and sales qualified leads and marketing leads. Like, no, you're not going to be fired for all those. If you are, you're working at a completely crazy company, you should probably update your LinkedIn profile. What you really are is figure out what is the thing that essentially the next person in the food chain cares about. So if we start with what most companies would start with, like revenue, that's a key performance indicator for the company. If that number goes to 0, we're all fired, right? Because we have no jobs. Cool. What number or possible combination of numbers leads to revenue? Closed won deals. And by the way, I should say, this will look a lot like a B2B example, but this applies to B2C just as well. You would just conduct the same style of exercise as a data scientist to try and suss out what numbers are we trying to calibrate on. From closed won deals, we have open deals. From open deals, we have sales qualified leads. From sales qualified leads, we of course have marketing qualified leads. From marketing qualified leads, we have prospects, and suspects, and audiences, and addressable audiences. And you can see we're starting to build a chain of evidence, a chain of connected numbers that will help us with our KPIs and help us answer the question, what decision are we going to make from our data science work? Think about who is responsible for these numbers, because one person's KPI is the next person's metric in most organizations, right? So if you are, for example, the VP of marketing and you're responsible for marketing and sales qualified leads, your sales professionals, that's going to be an input for them, a metric for them. Their KPI is going to be open deals that they were able to work and close. When we think about the business skills that a data scientist needs, it is one of which is to identify, when you're working on a particular piece of data, who is the stakeholder and what decisions will they make from it. If you're working with a VP of sales and they're worried about audience numbers, like, no, that's the brand manager's problem. Not to silo people unnecessarily, but if we're going to conduct an experiment, we want to focus on closed-won deals, not audience. That's upstream, and while audience will be an input to our experiment, it is not the thing that should be part and parcel of this experiment. So these types of business skills, and this is just one example, there are all sorts of things like SWOT analyses, pest analyses, Porter's 5 forces, all the business school models and frameworks that you maybe learned, are all part of those key skills that a data scientist needs. There's something that you cannot overlook, because otherwise you're operating in a vacuum. Otherwise you're operating without any context, and that can lead to wasting a whole bunch of time. The second area, scientific skills. What scientific skills do you need? The purpose of developing good scientific skills, and I think this is important whether or not you consider yourself a data scientist, is to be able to answer the question, is this reproducible? How many of us have had the experience where you run a campaign, or you're looking back in your analytics, from a year ago, whatever, and you see a couple of big spikes, and in one of the months past, you're like, oh gosh, man, we had a great results that month. Oh, it'd be nice to be able to do that again. And you ask, well, how do we do that? I don't know. I don't remember. I wasn't here. I didn't work here at that time. I was in a different department. We can't reproduce our successes, and without reproducibility, success is just luck. Right? We need to focus on how do we make success reproducible. And to do that, unsurprisingly, if we're focusing on scientific skills, the number one skill that you would need to have would be to understand the scientific method. Starting with that question, which, by the way, is where the business skills come in. What question we try and answer. Defining the problem, defining the data that we're going to need to answer that question, and then making a prediction, making a hypothesis, a provably true or false statement that we can then test, collect data about, analyze to find out whether our hypothesis is correct or not, refine it if we need to, and then deploy it and observe it as a theory. And again, we could take that theory, we could just put it into operation with a marketing team or a sales team, or maybe we take it down to engineering and have it be turned into a machine learning model or a piece of AI technology. But this scientific method is so important because in marketing, a lot of the time, we just kind of wing it. We kind of do stuff randomly, and then we can't go back and reproduce the results and create success over and over and over again. The most classic example of the way that marketers do this wrong, and I mentioned this earlier, is the A/B test, right? Most of the time, we just A/B test randomly. We change the wording. We have no hypothesis. We have no provably true or false single condition that we're going to test. And so we just kind of run tests randomly. That's a terrible way to do things. If you take nothing else away from this, when it comes to A/B testing, have a clearly stated hypothesis in mind before you start a test. And that means looking at your data, looking at the business requirements, and then figuring out what is it that we are actually trying to test. If you look at a website, you have copy, you have imagery, you have colors, calls to action. What provably true or false statement could you make about an A/B test? If you say, we're just going to test some buttons, that's not a true or false statement. If you say, we believe that changing the call to action button from green to blue will result in a 20% increase in conversion, that's a provably true or false single condition that we can test. We can test that, and we can see what the results are. Now, the good news is, from a software perspective, in today's scientific method, the test, collect, analyze phase can be automated. Many of you have probably used tools like, for example, the free Google Optimize that will do the testing, the collection, and the analysis for statistical significance. And in this particular example, the software didn't even find a leader. There was not enough data to prove the hypothesis true or false, but at least we know that now. We tested something. This is something I did on my website to test subscriptions to my newsletter. I had a hypothesis. It ran and said, your hypothesis effectively is null because there was no winner. So you were testing conditions that don't matter, right? So you want to have that true or false statement and make it as specifically true or false as possible. Not, hey, we think red is a better color. Okay, how much better? 5% better? 10% better? Over what period of time? 7 days? 14 days? 30 days? The more specific you are, the easier it is to test things. And developing that scientific mindset is so important. And it's not limited to somebody who was a scientist in school. You, regardless of your background, can learn this today, can put this into action today. Our third set of skills are the mathematical skills. And this is where everyone's stomach drops into their feet. Like, oh, what kind of math are we going to need to know? Mathematical skills are important because data is fundamentally in math form of some kind, either as a categorical variable, which is a non-number that you would quantify, or as actual numbers. And a lot of the times when we're working in data science, we're using math. We want to be able to answer the question, is whatever we're working on, the experiment, mathematically sound and valid? We need to be able to prove that what we're doing is relevant, is important, is significant, so that we can make a decision from it. So there's 4 techniques that, again, if you've taken a Stats 101 course in college and you were not hungover for it, you would remember these terms because this is all taught in Stats 101. And these 4 techniques are not complicated. Many of them you can do in just a spreadsheet. But what you want to be able to do is use them with your data to be able to judge the importance of things that you see in your data. Now, before we dig into the techniques, I want to say one thing about numbers in general. Numbers require comparison and contrast to have meaning. I saw a dashboard earlier today from another source that had all these numbers on it. It looked really cool. It looked like something like out of a movie, and it had fancy graphics and had numbers and flashing and all this stuff. But ultimately, there was just a pile of numbers on the screen. It's like my friend Avinash Kachik said, someone puked data all over the desk. Like, okay, yeah, you got 47,000 web visitors. Cool. So, is that good or bad? Is that up or down? We need to compare and contrast in order to make sense of our numbers. Take this screenshot from Google Analytics. It says I had 3,300 users to my personal website last December. Is that good? Is that bad? I don't know. There's no comparison. There's no contrast. When I add in year over year, now we have meaning, right? We have 2% fewer users this year than I did last year. Okay, something's wrong. Something's not working well here if I'm down year over year. Right, so being able to just do simple comparison and contrast of numbers you have from any source. It doesn't matter whether you're using digital, whether you're counting the number of people who walk by your billboard, you're counting the number of times you picked up a phone. Any number needs comparison and contrast in order to lend it some meaning. So there's 4 key techniques. The first is measures of centrality. Measures of centrality tell you what the middle number in a data set is. And again, we want to compare and contrast. We want to compare 2 or more measures of centrality to understand our data better. Let's take, again, that Google Analytics example. Here's that same data, just put in a bar chart form. This isn't particularly revelatory, right? Okay, here's the number of visitors I had. But if I rearrange it from most to least, now I can start to do things like, okay, there's definitely something going on here. There's one day where there's a big outsized thing, and there's a bunch of days where a whole bunch of things didn't happen. And if I apply some measures of centrality to it, I can start to understand it. In this case, the mean, which is the average for this period of time, was 415 page views. The median was 401. If you recall from Stats 101, the median is literally the middle number of the data set, and we see it occur here. It's 1215 and 13, that's 401. The average is when you add up all the numbers and divide by the number of rows. You say, great, so what? We know, because of the way centrality measures work, that when your mean is higher than your median, it means there are more outliers on the upper end pulling that mean up. The classic example is five ordinary people are sitting in a diner, and then Bill Gates walks in, and suddenly the average income of the room goes up to like $10 million. Well, did everyone just get richer? No, just had an outlier that pulled everything up. If that's happening in your data like this, it means that your campaigns probably are doing a better job than you would expect, because your average, you have more outliers than the upper end, right? So you have more things that are pulling that average apart from the median, and that means your campaigns are probably working pretty well. On the other hand, if the reverse is true, if your median is higher than your mean, that means you got more outliers on the lower end. Things are not working well, and it's a sign to immediately stop your marketing and figure out, what are we doing wrong that we can't get our campaigns to generate any kind of interest. So these measures of centrality, when you start putting them together, start to make a whole lot of sense to easily look at a data set. And again, applies to any data set. This could be number of phone calls that your sales center makes that are result in a sale or don't result in a sale. What's the mean and the median of those? Compare and contrast those. Go, oh, there are periods of time when we're doing way better, or there are periods of time when we're not in general, and we want to understand that. Now, one of the things you can do if you want to start to get fancy is to use what are called distributions. Distributions are bell curves. You're probably the most common one you've heard, the bell curve, where there's a little bit on each end and a whole bunch of stuff in the middle. Again, if I take that same data from Google Analytics, my data, and I arrange it into buckets or bins of numbers of days that had between 199.5 and 239.3 visitors. I had 3 days like that. And then the second bucket is 239.4 visitors to 279.2 visitors. There are 4 days that are like that. When I look at this distribution of my Google Analytics data, just putting the data into bins, I can draw a curve across that black line. And kind of like the old V8 commercial, that curve's leaning a little bit to the left. Actually, it's leaning a lot to the left. That tells me I've had more bad days than good ones. I've had more days where I've got lower traffic than I've had days where I've had higher traffic, and that's not good. Right? So I can look at this data set and go, why? What do those days have in common? If I look at the first 3 bars, I could go back in my data and look at what I was blogging about or making videos about in those days and go, these days we're not attracting traffic. We're not getting good results. I need to rethink what I'm doing. Again, this applies to any numerical data set. If it's the number of people who walk by a billboard or a bus station wrap, you can track that and then put this distribution together and say, is it a normal curve where there's a big bulge in the middle and 2 skinny ends? Is it leaning the other way? If it's leaning the other way, great. Figure out what you're doing and do more of that, because it's clearly working for you. But this diagnostic technique of building a distribution helps us to interpret our data and make it understandable. Now, the next technique is regression, which is a special way to look at how 2 different sets of data interact. By taking, in this case, the number of Twitter impressions per day I got and the number of users to my website that day, and put it 2x2 matrix, I can do what's called a regression to essentially find the line that has the least amount of distance from all these different dots. Now, a regression analysis tells us essentially a trend between 2 series and a relationship between these 2. If this line was a perfect diagonal line from the lower left to the upper right, it would mean that for every increase in Twitter impressions, I got an increase in users. That'd be a perfect correlation that would say, wow, there's a strong relationship here. And that would, in turn, let me make a decision. Well, if I want more Google Analytics users, I better get more Twitter impressions. In this case, I have a line going almost horizontal, which means there's no relationship. None. I can get all the Twitter impressions I want, and it's not going to make an ounce of difference to Google Analytics traffic. So now I can start to use these regression techniques to identify, is this a channel or a technique that can work for us? If I put Facebook users versus Google Analytics traffic, or I put phone calls versus completed sales. I could visualize any two data sets, find that regression between the two, and say, is there a relationship that would then let me start to construct a scientific test? And fourth is a technique called clustering. Clustering is when we take that data set and break it out into how data clumps together. We see that teal cluster at the top; those two kind of clump together. Those 2 days were interesting days. A clump in the middle that's kind of interesting. We have an orange clump and a blue clump of data. I could look at what was so special about the teal days. What was so special about the red days that was different than the blue and the orange days? Because those weren't as good, performing. What was different? What can I learn from that? Are there things that we did differently, different topics? Maybe one of those days was a sale or a special or something that got extra traffic to my website that the other days didn't have. And if you want to get super fancy, we can actually add regression lines on each of our clusters and say, you know what, maybe we don't throw away this Twitter thing entirely. Maybe we look at that teal line, which is going to that up and to the right line, and that dark blue line, which is also going up and to the right. And say maybe we figure out what we did on those 2 sets of days and do more of those things, but not do the things that we did on the red and orange days because that wasn't working as well. So even after we do our analysis, there's always more to find, to experiment with. So those are the mathematical skills, and we spend so much time on those because those are important, because you can do most of that in spreadsheets. A good chunk of that I did in Excel, except for the clustering. I did that in Tableau. The technology skills are the fourth sector of this, and I would say that the reason we want to pay attention to technology skills is to answer the question: can we scale this? Can we automate this? When you do a lot of work, particularly in pieces of software like Excel, you can do repeatable things, right? You can write formulas and stuff and repeat that, but it's very difficult to scale it. Once you get past a certain point, a spreadsheet's just not a good tool anymore because it can't be run by a machine over and over and over again. Right? You put together a great visualization or a great chart. In this case, I used some rolling averages to visualize some stuff, and this works for a one-time analysis. But if I had to do this every day, this would get super tedious. What I would do instead is maybe look at a tool like IBM Watson Studio, full disclosure, business partner of my company, and say, can I build the same logic using their drag and drop interface to do the analysis for me? And if I find that, as I advance in my career, that I start running into limitations, I want to do some customization and it just won't let me. That's when I bust out, in this case, the programming language R, that will let me do that analysis and write my own code and build really, really advanced models. For most people, most of the time, I think Watson Studio is a good intermediate step. But let me put it into 3 phases. For beginners, the tools I recommend you focus on: learn spreadsheets. As much as data science folks like to crap on things like Excel, guess what? They're one of the world's biggest and most popular tools for a reason, because you can do an awful lot in it. Use tools like Google Analytics. They can't do much of the analysis, but they are great data sources that produce clean data that you can train your skills on. And tools like Google Data Studio, a free way to visualize a lot of the data, especially if you use Google's spreadsheet software. These are great beginning tools for if you want to start doing data science. At the intermediate level, you want to look at tools like Watson Studio or Cognos or Tableau, advanced visualization tools that let you see results faster. You've got the data, you just need to be able to sort it and ask and explore more. And then at the advanced level, looking at tools like R, Python, SQL, JSON for dealing with NoSQL databases. These would be the high-end tools that you would need after you are advanced, after you've had some experience doing scientific experiments. Now, all these tools and math and things are great, but there's another side that's so important, so important, that gets neglected a lot, and that is the soft skills. And it sounds kind of silly, like soft skills for data science? That's inconceivable. There are 7 skills, though, that you need as a data scientist to be effective as a data scientist. Number 1, you have to be open. You have to be open as a person, being able to communicate with others, being able to share, to collaborate, to work well with other people. The stereotype of the hermit in their lab is actually not really a good archetype for a personality type for a data scientist, because in those 4 areas, business, technical, scientific, mathematical, you need to work with a lot of people. You need to work with a lot of individual subject matter experts. So you've got to be open. 2, you have to be resilient. Science is all about failure. Lots and lots of failure, trial and effort. Even if you're not using data science, if you're just talking about hard sciences like physics and chemistry and such, there's a lot of failure, tons of it, and you have to be able to bounce back. If the experiment fails, great, start over. The data was wrong, great, start over. You've got to be able to roll with those punches and deal with failure over and over again. You have to be curious. This is probably my second most important trait of a data scientist. You have to be curious. You have to be endlessly curious. The opposite is someone who is incurious. That is somebody who's like, no, I got like 15 things on my to-do list. I got 4 meetings booked back to back. I just need a number. Like, that's not curious. That's not wanting to get at the answer. That's not wanting to solve the mystery. That's just rushing through things. And the absolute worst personality type is somebody who has a preordained outcome in mind. Well, I promised the CEO that the answer to this would be 4% growth, so I need your research to say we're going to have 4% growth. That's not how it works. That's not how any of this works. So we want to make sure that you have that curiosity skill. You have to be patient. Science, because of its nature of trial and error, requires tremendous amounts of patience to get through the failures, to deal with them, and to wait. Before this webinar started, I set off a task of doing some text mining for a customer of ours on words that have appeared on their website or phrases that appear on their website so they can go through and tag pages. It was just fortuitous timing that the software finished running after 3.5 hours, 10 minutes before the webinar, so we could do this together. Otherwise, I would have had to start over again because obviously you don't want something that intensive running during a webinar. You have to be patient. You have to be persistent. Persistence is sort of the companion to resilience. Resilience is you can get back up after somebody punches you in the face. Persistence is you keep getting up after something or something punches you in the face over and over and over again. Especially if you're at a company where culturally data science is not a thing yet, you have to be able to be persistent politely to get buy-in. Number 6, you have to be humble. Again, you're going to collaborate a lot. In a lot of cases, you're going to create things that other people will use, but other people will be able to use the results and take credit for the whole thing. And you have to be okay with that, right? You have to be okay with, like, yes, I helped, but I was not the star of the show. And last, and I think the number one most important trait about a good data scientist is you have to be passionate. You have to love this stuff. You have to love solving mysteries. You have to love being curious. You have to love getting punched in the face. You have to love being uncomfortable, because an awful lot of the time you will do research and you will find answers that make other people unhappy. Yes, website visitors are down 34%. And the reason is that our website copy sucks. Right? That's going to be an uncomfortable conversation with the content marketing manager, isn't it? Yes, our sales volume is down 15% because the 5 people working in the front line on answering calls and sales are all morons who can't put 2 words together without pressuring somebody or saying something inappropriate on the phone. You got to love being uncomfortable, and that love comes from being passionate about finding the right answers. So those skills are important both as an individual and as something that has to be part and parcel of the culture of your company. If you don't have that, you're going to have a very, very tough road to hoe. All right. How do you get started with this stuff? First, assess yourself. Where are you with these combinations of skills? Right? What are you lacking in? What don't you have enough of? And then you have a couple of choices. How to either get those skills, or do you hire for them? And if you hire for them, do you get a person, or do you get an agency? The likelihood that you're going to get somebody who is extremely fluent in all 4 skills is not great. These are people who are described as unicorns, right? Most of the time, the realistic outcome for you as a company is going to be putting together a team of 2 or 3 or 4 people who have individual capabilities that you can then orchestrate and have something to work together. Somebody who's got a stats background, maybe they are a statistician. Somebody who's got a coding background. Someone who has a scientific background or a psychology background, or somebody who's been through the scientific method. You may be able to borrow from IT, somebody who has data engineering skills. You might be the domain expert or the business expert that can help guide things. But it's okay to have these skills that are distributed among a team of people, rather than try and look for that unicorn who, if they do exist in your industry, are going to be prohibitively expensive. To give you an example of how rare folks are in the data science field, for people, this is from a 2016 survey. I'm trying to remember who did it. I want to say it was like either Forrester or Gartner. There were 8,500 people in the United States who were qualified as data scientists with 4 years of experience or more. There are 14,500 marine biologists. There are more people who know about whales than there are data scientists. So you got to be very, very careful of that you're not going to find those unicorns because they are so few, and they are not cheap. A data scientist with 4 or 5 years of practical experience is going to cost you probably upwards of $300,000 a year. Right? They're just expensive people. Be very careful with hiring people who have gone through a so-called crash course in data science. 6-week crash course in data science. How comfortable would you feel going to someone who went to a 6-week crash course in surgery? I'd take the guy who went to med school. I think he's my chances are slightly better. There are a lot of companies that are cranking out people with these certifications, and they're good as starting points. That's the person you want as like a junior analyst, or maybe an apprentice data scientist to somebody on the team who has the experience, because they can be good talent in time. But just because somebody has that certification does not mean that they actually know anything. And the mark of a really good data scientist, of a really good expert in any profession, is that they know what's going to go wrong. Being an expert means you know what's going to go wrong and you can mitigate against it up front, as opposed to having things be a flaming wreck and trying to fix it. A qualified data scientist will look at your data, look at your analytics, look at your software and go, okay, here's the 14 things that I see wrong here. And we're going to have to fix this, this, and this. Otherwise, this experiment's never going to work. Right? That's what you're looking for. So we covered a lot in 45 minutes. I want to re-emphasize this most important part. Data science is the meaningful insights from data using the scientific method. All the tools, all the technology, all the mathematics, all the other stuff is secondary to using the scientific method, which means that no matter where you are in your career, no matter where you are in your skills, no matter where your company is in terms of resources, you can use the scientific method. Even if you haven't the foggiest clue how to operate, Watson Studio, you can come up with a hypothesis, you can test the hypothesis, you can collect data, and you can make changes for the better. Embracing that scientific mindset is so important for embracing what data science really means. And I would encourage you that be the takeaway from today. All this other stuff is great, and you'll get it all on the slides, and there'll be lots of starting points for you. But without the scientific method, you are not doing data science.
Want help solving your company's data analytics and digital marketing problems? Visit trustinsights.ai today and let us know how we can help you.